Total probability theorem. To understand total probability theorem, you have to see the conditional probability. First, you have to understand the conditional probability. So, what does conditional probability says? The probability of occurrence of an event A, given the probability of as B has already occurred, is equal to probability of A intersection B into probability of B. Conditional, this is definition of conditional probability. So now here comes the total probability of theorem. Total probability theorem. Total probability of theorem. Let's say this is the sample space. This is the sample space of an event, and there are multiple events. Event sample space 1, sample space 2, sample space 3, sample 4, 5, 6, 7, 8, 9, and let's take a sample space for probability of an, let's take an event A in this sample space. So we have to find the probability of occurrence of A. Now from conditional probability we can write P of A intersection B is equal to P of A by B given the P of B. Conditional probability, and to find the probability of event A we have to find intersection of all the sample points, all the sample space, and criteria for sample space B, each sample space B, every sample space should be independent events. Means the probability of occurring on S1 doesn't depend on probability of occurrence of S2, means each can occur independently. So probability of A we can write is equal to probability of A intersection S1 plus probability of A intersection S2 plus probability of A intersection Si. Let's there I sample space in a plane. Let's A touches with every sample point for here. Let's say this touches here, here. Let this be an event. So probability of A is equal to summation, you can write probability of A intersection Si for all I. Here we can see that if I equal to 1 to n. Let's say here, or we can write like this, I is equal to 1 to n, I equal to 1 to n probability of A intersection Si. But from here we can see that from conditional probability this, we can see that probability of A intersection B is equal to probability of A intersection B, probability of A given that B has occurred into B. So we can put it here, probability summation of this, every summation of P of A intersection Bi into probability of Bi I is equal to 1 to n. Hence, instead for each point, each point we are getting this. So for this equal to summation for all I, probability of A intersection Si, can write this, and this is the total probability theorem.